Hello, my name's Elijah, and today we'll be covering Internet protocols, or more specifically, IPv4 and IPv6 protocols. So let's kind of cover some basic properties that these protocols kind of share. Uh, One of them is the connection type is a host-to-host connection, which just means me being a host by owning a computer or a server, or it could be multiple things that can be a host, um, but it's just data transferring from a host to a separate host, one of them being a receiving host and one of them being the deliver host. And then the internet is kind of used to connect these two hosts together. And I think of it like a mailman. In a real world example, I'm sending a letter to somebody. I gotta put an address on there, and then I give it to the mail, or send it in the mailbox. Then the mail people will deliver it to the home. Well, the mail people in this instance would be the internet. Each host has a logical address, otherwise referred to as an IP address. So these are generally, a couple of numbers and then dot, a couple of numbers, dot, then like a couple of numbers. Usually 4 different segments of numbers, depending on how big the byte size is, but we'll get into that a little bit later. What is IPv4 and IPv6? IPv4 is simply version 4 of IP protocol. This version they felt like they got right, and it's honestly the most popular version on the internet today, or most commonly used within companies and others. It's very secure. It's it works. It's not as good as the IPv6, but the IPv6 is actually the less popular because of it's just a little bit more advanced. IPv6, however, is growing in popularity, and in the future it will be the main version. I can already see a lot of stuff transferring over. We're not quite to that point yet, but I mean, it's definitely gonna get there. Okay, so next thing we kind of need to cover is the IP address byte size. So this is actually different between the two protocols specifically, and then there's also in the earlier version kind of like a 10 byte, but we won't really cover that until our example. The IP addresses are made up of a set number of bytes that vary in size. So it could be different sizes. This is usually the way you would word it would be like 10-bit or 32-bit. And that's just the first number is telling you how many bits are in it, and then that it is a bit at the end. Bits are strings of binary code comprised of ones and zeros. So 00111110 is like a binary number, binary string. 11111111 is binary string. But let's talk about the binary string specifically for IP addresses, because they're a little bit different. They're kind of limited. The IP address for a 10-bit would look the binary code for a 10-bit would look something like 1011100101. If you notice, the number is digit-wise is the same as 10 digits, so that makes it 10 bits. IPv4 contains a byte size of 32, and the less commonly used IPv6 contains 128 bytes. Okay, now that we've kind of talked about all that stuff, let's get more into the meat and potatoes and talk about networking classes. So there are different types of classes that are delegated to the networks, and how you choose between the different classes is basically a different number of hosts. So how many hosts is it compatible with? Um, Also, through the use of classes, we can introduce subnetting, which makes everything a lot easier. And we'll get into kind of subnetting in the next slide. But it makes things, it splits your network up so you can cover a wider area. You can delegate specific tasks to specific things. There's a lot of good stuff you can do with subnetting, which makes network classes like a must-have. In most situations. There are still some situations where you definitely want to use something else, but again, we'll get into that a little later. The IP that belongs with 127 are reserved for loopback. So loopback is basically to test things, trial and error, stuff like that. So you just think about it. Whenever I say the IP that begins with 127, I mean like 127 dot like X, or not X, but like dot something dot something dot something. And then the last host ID is actually reserved for broadcasts specifically. So, yeah. Okay, so like I said before, we're going to get a little bit into IP subnetting. IPv4 and IPv6 connections are compatible of splitting into separate pieces known as fragmentation. Like I said, this is very good for, delegating different tasks, objectives, things of this nature. Here's a little example that I've given, and I'm going to try and explain it in the visual sense. If a router is receiving 5,000 bytes of data, it will separate the majority of the data given with a slight data loss from the header. So if the network has been subnetted and it has 5,000 bytes available, and it's splitting them into 3 different IP, it'll be IP1, IP2, IP3, then give or take, there will be at around 1,500, 1,600 bytes. Now, if you do the math, that doesn't equal up to 5,000. There's a little data loss with the header, but in general, they'll equal to about the same capacity as the IPs available for. So, and then like I just said, their separated data is labeled from IP1, IP2, so on and so forth. You can have more than 3, you could have 5, you can have quite a bit of these. And that's going to kind of depend on the class you pick between A and E, so be careful of that. Okay, classless interdomain routing, also known as supernetting. So supernetting is actually the opposite of subnetting. Supernetting is a bunch of networks coming together. It combines them for more powerful processes, and for as far as the subnet mask, it'll actually make it longer, and based on what you're working with, it can actually vary in length. So very powerful, very, very nice for making things super powerful if you need that extra juice, or there's a lot of situations where classless interdomain routing is needed. So this is the conclusion of the video. We kind of covered what is a IPv4 and IPv6 protocol, the byte size amount for the protocols, so like how many bits, ones and zeros the protocols each have. We talked about how networking classes and why they're important, especially for subnetting. We talked about how subnetting kind of splits the networks, up. And we talked about classless interdomain routing, which is the opposite of subnetting, which is supernetting, and can be used in a lot of situations that help. Thank you.